I've been writing shell scripts now for over a decade, and only recently did I learn a little bit more around how file redirects work. So for example, you can do something like echo hello, right? That's going to print this output here to standard out, and there it is. And we can also redirect this to a file, right? So if we do that, and then cut out this file here, we would expect to see the contents of hello, right? Totally normal, totally expected. Now, check this out. Let's do something a little bit more complicated, but nothing too crazy. And here, we're taking that same echo hello. In this case here, we're going to sleep for 5 seconds, echo out that hello, and then write the file here. The reason why we're using awk is instead of just normal sleep 5 here is because the awk command will accept input, in this case, the hello text here, and then also produce output, whereas a sleep command would not. So what do you think is going to happen if we run this script? Well, I'll tell you what I thought initially for the last 10 years. I kind of thought like, okay, echo command's going to run, it's going to produce some output here, that's going to get piped into awk. Awk is going to be like, I understand standard in, let me take that, I'll do whatever I need to do here, in this case, sleep for 5 seconds, and then I'll produce some output here, and then the file is going to be created on disk. But that's not exactly what happens at all, and can actually result in some data loss depending on what you're doing. So let's run the script and see what happens. So demo redirect. Now, before I run the script here, pay very, very, very close attention to my sidebar up here. In this case here, I'm going to delete that results file just so nothing is there, but I'm going to run it right now and then immediately move your eyeballs over here. So 3, 2, 1, bam, look, immediately the file was created. The script is still running, it's doing its sleep, and then the script finishes. However, this results file was created immediately, right, as soon as this command was being run. Now, if we take a look here at the results file, we can just cut it out. It is going to give our results here of hello with a capital H, just like we saw over here. But the order of operations here maybe is a little bit unexpected, or at least it was for me. So what really happened here is this results file was immediately created on disk. Now I'm saying immediately, but whatever, within milliseconds here. And these processes were all executed in parallel. And in this case here, echo and awk, but it's basically just streaming data to that file, as needed. So you can imagine there could be some issue here with data loss. This is kind of a contrived example, but imagine you're doing something like, I don't know, Postgres or MySQL, and you're doing a database dump. Maybe you're piping it into gzip if you're doing like a pg dump all, which is going to be uncompressed. And then maybe you're redirecting that to a file to do your daily backup. And maybe this file here is always the same file because maybe you just overwrite the same backup every day. So if that backup command failed for some reason, maybe it's, running through the pg dump, which is then streaming data into gzip, which is then streaming those bytes out to this file here. If that dump failed, like, I don't know, 20% of the way through, then your backup could be corrupted here. That's going to overwrite the existing backup file that was there. Then maybe worst case scenario, disaster strikes and it's like, oh no, I need to restore from my backup. But it's like, oh no, the backup is only 20% there. And now you're in trouble unless you had it backed up in another spot. And you might be thinking like, okay, well, that's like kind of interesting. It certainly was for me, but you might change this around a little bit to use T instead, right? Instead of just redirecting to the file like this. So there's another demo here with T. Let me also delete this file just so we don't have anything there. And this does the same thing, right? Hello, go into awk, sleep for 5 seconds, produce the output there. But now instead of just redirecting to the file, we are going to call T here, and T is going to write out this file here. I'm also just choosing to take standard out and just redirect it to dev null so it doesn't get printed to the terminal here. But we can go and rerun this here, or just run this command here with T, and then we'll see what happens. Again, eyeballs to the top left, we can see here, I'm going to run this in 3, 2, 1, boom, there it goes. There's a results file. It's completely empty right now. It was before too, I didn't show that, but look, the command is still running. Now the command is done, and now the contents here is in the file. So basically the same thing is happening here, right? These things are being executed in parallel. T understands like, hey, by the way, I need to create a file for output. Let me open up a file descriptor for that one. And then these guys over here are just streaming their data to that file, and then eventually everything is good to go. But yeah, that's, these happy case, right? Everything is good to go. But again, these commands fail for some reason. Suddenly things aren't working as expected. And what's actually pretty cool too is we can do this safely in one way, but before we get there, we could actually use something like strace to verify what's happening here. Now, these commands I always forget off the top of my head, so, I do have a blog post related to this here as well. We kind of went over some stuff here, blah, 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 showing the problem, yep. Here's the actual, how it's actually happening there. Now, one thing that is pretty interesting worth talking about here is, the important takeaway, right? As soon as that pipeline starts to run, then that file you're redirecting to, yeah, it's been truncated to 0 bytes. And then really there's like 3 possible states that file can be after the script finishes, right? Like all the commands finish successfully, just like we saw there. But yeah, maybe one of the commands fails and the script exits with a partially written file, right? There's your corrupted database backup or whatever it happens to be. Or maybe there's some outlier event here where, the script just begins executing there. Then maybe there's a power outage or something happens and the file's completely empty because nothing really had a chance to run. And then, yeah, we go over using T, blah, 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 same problem. Here's the actual problem. But yeah, using strace here, let's go and take a look here and see some of the outputs that we're going to take a look at. I'll zoom in as well. In this case here, let's do it demo on redirect, I guess, will be the file here, because in the blog post there's only one file name. Not important here, but yeah, let's run this for a second. If you're on Mac OS, you won't be able to follow along. No worries, but we'll show some outputs here, just like the low-level system calls and what's happening. So if we go all the way up to the top here, we're running strace. We need to follow forks because the shell is going to be forking out to those processes there. We want to learn some information about them there. And then, yeah, we're going to trace basically this open out call here on this one script. And we're going to look basically for truncate here. So eyeballs, eyeballs, eyeballs. Let me scroll down a little bit. There it is. Cool. So this line over here, then you can see this O_truncate here on the results file. So like right away when this process is being started, whatever, some libraries are being loaded, blah, blah, blah. Yeah, this file is being created here, a truncated file, 0 bytes. And then all sorts of different things are happening. All sorts of different processes are doing whatever they need to do. And then they're going to be streaming data to that file as needed. But yeah, that kind of verifies that that happens in that type of order here. And if we do the same strace here on the T version, then we're going to see similar type of outputs, slightly different calls here or there. But in the end, we will see that results file being truncated too. And actually, what's kind of interesting too about this one with the T one is, you can see there's a T here. Take a look at this here. These processes here, those 3 commands in our pipeline are all being run in parallel here. There's no timestamp here, but, these are all being spawned within, I don't know, microseconds or milliseconds of each other. And then, yeah, eventually we'll just see that results file here with the truncate, and there it is over here. And there we go. So yeah, it's kind of a neat little way of diving a little bit deeper with the strace here, just to see a little bit more details on how things are actually happening. So if we go back to that, yep, diving deeper, blah, 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 so yeah, writing files safely, what could we actually do here? So let's go back to our example that we're looking at here, and then we can take a look at the safe example. Let me also delete this file here so we just have, something clean to work with. But yeah, in this case here, we're breaking things up into multiple operations. So we're still going to be redirecting to the file. And if you wanted to use T here instead, that's fine. Both will work in the way that we want to do for this example here. But yeah, in this case here, we are redirecting this to a temp file. Again, this extension could be whatever you want it to be, just something that's not your real file. And then after this pipeline has completely finished, the file has been completely redirected, then we're just going to move that results temp file to the results file is what we want in the end. So if you run this one here, demo safe, then this one is going to do the same thing. Again, eyeballs top left, we hit enter, bam, results temp, it's an empty file. Things are happening, it's sleeping, it's blah, blah, blah. Awk is going to finish sleeping soon. It wrote the file. And yeah, in this case here, it actually wrote nothing to this file here. Why? Let me take a look. Oh, there it is. So that was my bad there. I had the old file open here, but remember it got moved to this file here. So yeah, I just couldn't double click it like before. So, but in any case here, yep, everything worked as intended here. Now, the benefit here, right, is this has a chance to finish completely successfully. We have error, exit, and pipe fail up top here. So if any part of these commands fail, then we'll never get to the point where we can actually move over and overwrite the original here. Having error, exit, and pipe fail is really important in this case. But yeah, after this, move is going to move file A to move to file B. And since these are both on the same file system, then this is an atomic rename. So basically we can get a guarantee that the produced file here on the right is going to be what we want here on the left. It's going to be the full file in its entirety. Now, as for why we're keeping the temp file on the same file system as the real file, that is because of how move works. So if both of these files exist on the same file system, then move is able to do an atomic rename, meaning the results here that you get, for the main file that you want, we're pretty much guaranteed that it will be the results of the temp file here. If these were on different file systems, then that file needs to be copied across, and that's no longer an atomic rename. There could be a chance for data corruption there potentially. It would technically be pretty low chance, but hey, it can definitely happen. But in this case here, yeah, I'm using temp in the same directory. That pretty much guarantees us that these are going to be on the same file system, right? For example, if we took this temp file here and just put it into, /temp instead or something like that, then no longer are we guaranteed that these are on the same file system just by looking at the script. Maybe temp is mounted to a RAM disk and this is not, right? That's pretty common on at least Linux desktop machines. In fact, I'm pretty sure I have that set up here. For example, if I go and do, DFH here, we can see, yeah, temp is set to temp file system here. Yeah, so, that's one example there. On a server, that typically wouldn't happen, but again, it really depends on how you have things set up here. So that's just some information to be aware of here. And yeah, let me go back to the blog post, make sure I don't forget anything here. Yep, we have 2 partitions, separate disks, blah, blah, blah. It's going to copy, not do atomic rename. But yeah, let's go here and just do maybe a one-liner here to demonstrate this actually works how we want. So if we go and take a look here at the bottom one, basically what we're doing here, we're just creating a file using strace to trace this move command. We're just moving this file to a temp file, and then we're just going to remove the temp file at the end. So let's run that and see what happens. And we can see here that, we're doing a rename at 2. We're just taking a look here on my machine, modern version of Linux using Arch Linux. It's going to use this system call. Maybe on a different distro, it could use rename at. But in any case here, we can see there was exit code 0. Everything worked. It did a no replace rename. Good to go. Now going back to the blog post here, here's another example where it is not going to operate the same, at least on my machine, because as we just saw, temp is not on the same file system, but same idea. We're going to touch a file here, same system calls that we're going to monitor. Then we're going to move it to a temp directory A instead, and then just remove it from there. So if we do that, we can actually see like, hey, look at that, invalid cross device link. We're not able to move the file. Now in this case, we're only looking at these system calls here. A rename didn't occur. Instead, the file was actually copied over. The file was still there. It's just, moved in a different way where the bytes actually got copied, not moved. So that, yeah, it's a really important thing there. Some considerations of this approach here that we're doing, right? The temporary file that we're going to move, basically. The upside, right? It lets your pipeline operate normally. Data is going to be streamed into the file without needing to hold everything in memory. And of course, the amount of memory used will totally depend on the tools that you're using to process your data, right? If you're doing something like a database dump, piping it into gzip, that might be chunked out, I don't know how many bytes at a time, right? But it's going to do a little bit, and then it's going to do a little bit, and a little bit, and a little bit, and eventually at the end, your file is going to have the full thing if the command finished successfully. Now, one downside or consideration to think about here is you do temporarily need double the storage in the database backup example. Of course, this strategy can be used for other things. I kind of feel that a database backup is a pretty reasonable example. But yeah, you need the old original full backup that you had from, let's say, yesterday, but you also need that new temp file being backed up today to exist in parallel for a very short period of time until move can do its thing, right? So yeah, just be a little bit mindful of that there. Now, personally, this redirect to temp file plus move combo is what I used in most cases here. Funny enough, I've actually been using this approach to backup databases for a really long time, probably around a decade. And I was recently doing some client work and I revisited some of my old backup and restore scripts. And, I just wanted to justify my thought process. So I did a deeper dive because I was looking at those scripts and I'm like, why exactly again did I actually just go to a temp file and then move it? And yeah, I actually stumbled upon that solution, like a safe solution there, just based on intuition back then. I just figured like, oh, let me just like make it go to a temp file first and then, move it into the final destination. I didn't know that actually redirecting to a file here would just zero out that file right away. But yeah, now I know. And, if we're talking about backups too, right, of course, you consider using S3 or another object store, and that's good too, right? This example kind of focused on just backing up to a mounted drive. This drive could exist on a different file system than your database, which would be a good idea, right? You want to have redundancy across your drives here, but that move is still an atomic rename here since the temporary backup file and the real backup file are ideally on the same file system, right? Database can totally be separate. But yeah, that's about it for this video. Kind of interesting, I suppose. So let us know in the comments below if you have any questions. I'll do my best to answer all of them. With that said, if you liked the video, please give a thumbs up. Really does help a lot. Thanks a lot for watching, and I'll see you in the next one.